So good morning and welcome to this lecture. In this lecture, what we are going to cover is that since we have covered sufficient theory of physical and cognitive ergonomics, now we will try to solve some of the questions related to physical ergonomics today, so that the understanding towards the theory and related applications could be well understood. So in series with that, I'm going to continue with I'm going to start with applied problems in physical ergonomics. So let's have a first question that is in the slide itself, and that is based on the calculation of calorie content in the foods. So this 3-ounce package of dry soup ingredients is mixed with boiling water to make 1 serving of cheddar cheese and noodle soup. This particular mixture contains 1190 milligram of sodium, that is in salt, and 16 gram of fat and 38 gram of carbohydrate, including 1 gram of sugars and 7 gram of protein. So use the energy data in the table to determine the number of calories in the serving. So here, how will you calculate the number of calories? Since why these things are essential, because all kinds of work activities require physical efforts, and for doing those physical work we need some energy, and energy is only obtained by the food you intake. So if you will be aware of the calorie content in that particular food, so it will be easy for you to estimate, in fact a rough estimation of what you are taking on daily basis, and how much effort physically you are applying to get your work done. So this knowledge is essential, and in this way you will be physically fit, and that's why the ergonomic purpose will be solved. So how will we attempt this question? So since if you recall the past theory that we understood while tackling this physical ergonomic topic, so there was basic chart. I am revising that chart also. So that chart was based on the basic nutrients along with the calorie content, in which there are 3 basic nutrients that we described. So carbohydrate is containing 4 kilocalorie per gram, and protein is containing 4 kilocalorie per gram, as well as this lipid, or named as fat, it is 9 kilocalorie per gram. So now the question becomes simpler, and so the total kilocalorie, since it has to be calculated per serving, so total kilocalorie per serving will be calculated as, since here the data is giving you, so according to the data available in the numerical, so the carbohydrate that is given as 38 gram of carbohydrate, it means 38 gram of carbohydrate. Protein is given as 7 gram, and this fat is the value of fat is this particular 16 gram of fat. So as a calculation of number of calories, these nutrients are only the involving factors in that particular energy calculation. So only carbohydrates, protein and fat will be in consideration, and we will not consider this amount of sodium in our calculation. So the total kilocalorie per serving will be equal to the number of calories provided by carbohydrate plus number of calories provided by protein and number of calories in fat. So now total kilocalorie per serving will be as, since if we start with, let's say, this carbohydrate, so 4 into 38 plus this times this, so 4 into 7 plus this into this, so 16 into 9. So as a whole, if you just multiply these factors, these three factors, and make a sum of that, so you will find out the value as 324 kilocalorie. So in this way you can calculate the number of calories per serving, whether it be a soup or any food. So here there is another example which is based on your metabolism. So the question I have put is saying that a male worker consumes food containing a total of 3500 calories, that is expressed in a kilocalorie, and each day he is 60 years old and weighs 200 pounds. He sleeps 8 hours each night, and his average energy expenditure rate is, while sleeping, is assumed to be his basal metabolic rate. So when he is not working or sleeping, his energy expenditure rates averages 1.7 kilocalorie per minute. No correction for weight. What must be his average energy expenditure rate that can be expressed in kilocalorie per minute for the 8 hours he works? If it is perfectly balanced with his food calories intake, his digestive metabolism is assumed to be 10% of the total of his basal and activity metabolic rates over the 24 hours of the day. So here you have to recall the theory which we studied in metabolism, in fact in physical ergonomics, metabolism and the energy expenditure rate. So here what you need to calculate, you have to calculate the BMR H per kilogram. Firstly you have to calculate this, and then you have to calculate this particular BMR on the daily basis, followed by total metabolic rate on the daily basis, and then followed by average energy expenditure rate. So this is the rough steps you have to follow in order to calculate this average energy expenditure rate. So now first we need to calculate this basal metabolic rate per hour per kilogram. So as you may recall that for 20 years old male, so BMR per kilogram is 1 kilocalorie per hour per kilogram of the body weight. And as person ages, his basal metabolism rate declines slowly, so the age correction is simply to subtract. So basically, as person advances in terms of his age, his basal metabolism rate declines slowly, so that the age correction can be calculated as by subtracting 2% from preceding values for each decade. So in this way, and that is each decade after 20 years. So as per the rule for calculating this basal metabolic rate, so as person ages, his basal metabolism rate declines slowly, so the age correction is simply to subtract 2% from preceding values for each decade over 20 years. So as the age passes, you have to accordingly calculate the age correction factor. So now how will we calculate this particular age factor? So since as per the problem, this particular male person is 60 years old. So since he is 60 years old, so we can write it as he is let us say 4 decades older than 20 years. I hope you have understood this fact. It is like that, the 60 will be how much? 20 plus 40, and 1 decade consists of 10 years. So this can be as 20 plus 4 times 10. So we can say that this particular person is 4 decade, so 10 is a decade, so 4 decades older than 20 years. So in this way the age correction will be 4 into 0.08, that will be equal to 0.08. So as you may recall the fact that this what is metabolism and what is basal metabolic rate. So in that this particular basal metabolism is what? That minimum amount of energy used by the human body when it is in resting, when it is at rest condition, when there is no as such digestive action is occurring inside the body. So that particular minimum amount of energy is known as basal metabolism. So taking care of these fundamentals in mind, so basically the energy used only to sustain the vital circulatory and respiratory functions is measured as a basal metabolism rate. So in this way, so adjusted BMR per kilogram value will be 1 minus 0.08, that will be equal to 0.92 kilocalorie per hour per kilogram. So in this way this particular value is calculated, and so this particular value can be converted, this value can be converted to an like equivalent BMR value per minute by just dividing the number of minutes in a 24 hours period. So how we will calculate this as like BMRM equals to 0.92. So this particular weight is 200 pound. So here we have to eliminate this per kilogram and per hour. So how we will do that? So into 200 upon 2.2 upon 60, so that will be something like 1.394 kilocalorie per minute. So now since this particular BMR value per minute has been calculated, so now the time is to calculate each energy expenditure rate for all the activities that he is performing. So what he is performing? He is performing sleeping, he is doing some work for 8 hours and other work also. So we can make a table for listing all his activity and time he is devoting to perform a particular activity, as well as energy expenditure, and lastly the total energy. So first kind of activity is sleeping. So sleeping, how much time it is taking? So he is sleeping for 8 hours. So 8 if we calculating in minute, so 8 into 60 is equal to 480 minutes. Corresponding energy expenditure will be 1.394 kilocalorie per minute. And if you talk about the total energy, so you will have to multiply this, so some sort of this 669 kilocalorie will come out. As far as work is concerned, so again how much work he is doing? He is doing work for 8 hours. So again 8 and if you convert it into minute, so 8 into 60 equals to 480, and this energy expenditure rate will be unknown, and so 480 times ER will be in kilocalorie. And as far as other work is concerned, so it is also he is doing for other work, we have to consider as a 480 minute, and that is 1.7 kilocalorie per minute, and that if you multiply it will be 1816 kilocalorie. So now we need to calculate, so if you could sum, so BMR per day plus this activity daily activity metabolic rate AMRD will be equal to 1485 plus 480 into energy expenditure rate. So since what the question is saying that his digestive metabolism is assumed to be 10% of the total of his basal metabolic rate over the 24 hours of the day. So we have to calculate this digestive metabolic rate as 0.10 times BMRD plus AMRD, that will be equal to 0.10 times 1485 plus 480 times ER. So if you add these 1 and 2, so you will get as a total metabolic rate, which is the sum of the three types, BMR plus AMR plus this DMR. So we will sum up as 1.10 times 1485 plus 480 energy expenditure rate. So this we have added 1 plus 2 we have added. This is daily total daily metabolic rate, which is expressed in kilocalorie per day, and this 1.10 times 1485 plus 480 times ER. So here we can write it as a 1634 plus 528 times ER. So now we have as a food calories. So he consumes food containing total of 3500 kilocalorie. So now as a total food calories, what we have we have 3500 kilocalories. So and the total metabolic rate on the daily basis we have calculated as 1634 plus 528 ER. So in this way we can calculate as ER equals to 3500 minus 1634 upon 528. So this will be after evaluation come out as a 3.53 kilocalorie per minute. So in this way you can calculate this particular energy expenditure rate with the help of the formula that we have learned in the theory class. So another question that is for you to solve, and that is, a male worker performs a task during the 4 hours of the morning, and that has an energy expenditure rate of 6 kilocalorie per minute. Determine how much of this 4-hour period should be allowed for rest breaks, and the energy expenditure rate during the rest breaks is 1.5 minute. Use a maximum time weighted average energy expenditure rate of 5 kilocalorie per minute as the standard or recommended level. So as you may recall, we have learned the formula to calculate this rest period. So that the formula I am writing here, it is nothing but the total energy conservation concept. So total time you can write as a basically the rest time you can write as a WRK ER, WRK minus energy expenditure. So this is the energy expenditure rate minus ER RST, where this TRST is the rest time. In fact, I am writing here. So TRST equals to rest time, is the working time, and WRK equals to energy expenditure rate associated with physical activity, that is expressed in kilocalorie per minute, and this particular ER bar is average acceptable energy expenditure rate. So these are the given explanation of the particular terminologies that we have used in the formula, and now we have to read the question again and pick up the given things. So here working time is given as is 4-hour period. So TWRK is equal to 4 hours. As well as energy expenditure rate is concerned, so ER work, the energy expenditure rate associated with physical activity is energy expenditure rate of 6 kilocalorie per minute. So this is 6 kilocalorie per minute. And as far as average acceptable energy expenditure rate is concerned, so it is given as a 5 kilocalorie per minute. So we will use as ER bar equals to 5 kilocalorie per minute and this particular energy expenditure rate during the rest breaks is 1.5 minute. So T rest is given as basically before that this particular thing is given as rest equals to 1.5 minute. So in this formula, if you see this particular WRK is given as a 4 hour, ER work is given as 6 calorie per minute, and ER bar is 5 kilocalorie per minute. This is given, and energy expenditure rate associated with the rest break is given. So now everything is given on the right hand side. Now you have to calculate the left hand side. That will be TRS equals to 6 minus 5 upon 6 minus 1.5. If you will calculate at 4 into 1 upon 4.5, this will be particularly, so since T work is given in hour, so we have to convert it in minute. So into 60 we have to do 240 minutes. So here we need to multiply with 60 into 60. So something will come out like 53.33 minute. So all things you have to convert in 1 unit, that is in minute, and then you have to apply to this formula and get the result in a positive way. So this is all about calculating the rest period, and rest period, taking rest is very important when you are performing any work for a longer period of time. So it is helpful for all your metabolism and all the organs related to your functioning of a human body. So so in order to have proper functioning for longer time, you require a rest period, and that rest period you can calculate with the help of these theories that we covered in the physical ergonomic part. So another question that we will solve and that is very much important as far as our body proportion is concerned, because your weight should be proportionate towards your height as far as your proper efficiency is concerned. So we will solve this particular question, as well as we will try to understand the theory behind this body mass index and how you can roughly estimate whether your body is perfect or not with the help of this body mass index. So body mass index is nothing but that is expressed in this body mass index. In fact, first we will read this particular question, and then we will understand the theory behind that. So what we need to calculate is compute the body mass index of a person who weighs 190 pound and is 55 feet 9 inch tall, and how would this person be classified using BMI classification. So this basically, this B for body M for mass and I for index. So this BMI, this particular index is based on one's weight and height, and it can be calculated using the formula BMI equals to W upon H square if W is weight in kilogram and H is the height is in meter. If you want to convert it into this unit, that is pound per inch, so some additional factor will be coming as BMI equals to 703 into W upon this H square, where W is the body weight in pound and H is the standing height in inch. So this is a formula you have to keep in mind in order to calculate body mass index. So there is a BMI classification I am giving here. So here I am giving you BMI value and its interpretation. So if BMI is less than 18.5, if 18.5, if BMI is in between 18.5 to 25, if BMI is in between 25 and 30, and if BMI is between 30 and 40. So what could be the interpretation? So if it is less than 18.5, so your body will be underweight, and if it is in between 18.5 to 25, it is ideal. If it is between 25 to 30, so you will be said as an overweight, and if you are in between 30 to 40, you will be having somewhat obesity you will be having. And if BMI is greater than 40, so you are suffering from morbidly obesity. So morbidly obese is the extreme condition. So now coming back to the this is obese, okay, OBESE. Now coming back to our question, that what is being asked, that how would this person be classified using BMI classification. So here is the classification. So now using the formula, since it is given in pound and inch, so we will use equation 2. So in that BMI equals to 703 into W is 190 upon 690 square. So there, if you calculate this thing, you will get 28.06. So this particular 28.06, now we have to see in which category it is lying in BMI classification. So this 20.6 is lying in this category. So it means that the person is overweight. So in the similar way, you can calculate your own body mass index, and this is the classification is given in this table. So you just calculate and become aware of your body mass index, whether you are underweight or you are an ideal body, or you are overweight or obese or morbidly obese. So in this way you can calculate your body mass index. Now there is the one questions we attempted and we recalled our theory also. So this particular ergonomics is a very much interesting topic in order to because it in order to understand the facts that are responsible for your performance, and since it is mostly revolve around the human, so human study is very much important here, because it is the human that does the work. So various aspects related to human, whether it be a physical, cognitive or social or psychological, so all aspects we need to understand for developing understanding towards ergonomic topic. So ergonomics is also known as human factors engineering. So we need to understand what are the human factors and what kind of engineering is involved, or what kind of discipline is required to do required to study to understand this human factor engineering, or called as an ergonomic. So in that there are various human factors like physical and mental work capacity. Human also suffer from fatigue. So human have a strength, and he changes posture time to time. So and if you put some if you, let's say, if you do some manual task, suppose you lift some object, so the various joints and body part experiences forces. So the analysis of body forces, body size is also important, and this because of this body size variability, this ergonomic has become a matter of study, because a particular design, whether it be a work system design or product design, is not suitable for all kind of body, because of the body size variability which we as a human being have. We also require thermal comfort, and we also need to take care of heat and cold stresses. We also have vision, hearing, we perceive information, and we also perform information processing. We also do decision making. We also take care of the performance and efficiency, and we also take care of behavior and social relations. So all these aspects are the human factors, because of which we discretize all this complete syllabus of applied ergonomics in these aspects. So physical and mental work capacity and fatigue we dealt in this physical ergonomic part. Body forces we will be discussing in the biomechanics, and as far as thermal comfort and vision, hearing, perception, information processing is concerned, we covered this physical work environment part and cognitive ergonomic part, in which we learned about the human information processing model, in which we discussed, in which we covered the functioning of various human senses, sensory organs, and its relation to our responses, detection and recognition, that is in the form of information processing and decision making, as well as performance and efficiency. And some sort of cognitive psychology part we also dealt in the each slide of the very last slide. We discussed some of the historical part of the cognitive psychology, in order to cover what have researchers done in the previous moment of time. So these are all the human related factors, and which needs engineering analysis. So if some sort of workspace design or product design is concerned, so it comes in the industrial design, where workplace design and product design comes into picture. If as far as body force relaxation and posture comfortability is concerned, so in that regime we take care of design whether it be furniture design, machine design, or as far as thermal comfort is concerned, we take care of ventilation, lighting and acoustics, and as far as other areas are concerned, we take care of engineering control, whether it be chemical or physical, and building orientations, where the building is basically a space or a place where all workers used to perform their work. So a suitable ambient need to be produced in order to get the workers comfortability, so that they could perform exceedingly well in whatever the task they have been assigned for. So in this way, this human factors engineering is important in each and every aspect we can think of. So in a nutshell, the aim of ergonomic is to ensure that human needs for safe and efficient working met in the design of work system. So aim of ergonomic is to design appliances, technical systems and tasks in such a way so as to improve human safety, health and comfort and performance. The ergonomic also improves the efficiency in purposeful activity. It is helpful in achieving desired result without waste. The minimum waste principle is also lying in the ergonomic area of a study. So error has to be minimized, and we have to take care of the damage to the persons, because human life is important, and as well as if a sudden disasters or damage happens, so it directly affects the person's life. So that is also area of a study in ergonomic. We have to develop the working situation in harmony with the activities of the worker. So because of dealing all the possible aspects related to human comfortability and human efficiency, the benefits of ergonomics are: this ergonomist focus to gain productivity, product quality. It is responsibility to take care of the safety, ensuring health, reliability, job satisfaction as well as personal development. So that's all for now. In the next lecture we will do some numerical analysis and as well as some revision of cognitive ergonomic part. Till then, thank you.